not, it's okay. We'll go over it. So identify a pair of lines that are parallel or perpendicular. Really quick recap. Parallel means that you're running beside each other. It's kind of like train tracks. Right. They never touch. They never go like cross each other. Perpendicular means that it creates a 90-degree angle. Okay. So parallel means that they're going to have the same slope. Okay. Perpendicular means that we're going to have the negative reciprocals of each other. And I'll talk through what that actually means. Reciprocal is flipped. Yeah. So if I have something like this negative 3x plus 2, which one is parallel to it? Which one is parallel to it? That means that it has the same slope. Exactly. Okay. So those are parallel to each other. Okay. Now, if I have something like this negative 1/2 x plus 3, which one is perpendicular? That means that it's the negative reciprocal. That means that you're going to change the sign and flip the fraction. Exactly. Okay, so these are going to be perpendicular to each other.
Oh, okay, I get it.
Okay. Now, exactly. Yep. Now these other two that are just J chilling, okay, they have nothing going on. They're just two lines. Okay. They're not parallel. They're not perpendicular. They mean nothing to each other. That's really sad. That's really sad. I'm so sorry. They mean nothing to each other. Okay, so again, you're going to entitle this parallel and perpendicular line proofs. And I want you to get comfortable with using these so you don't actually have to write it out. Parallel is 2 lines. Perpendicular is an upside down T. Okay. Take a second, write that. All right, so really quick, what do you know about the sides of a parallelogram that could help you prove ABCD is a parallelogram? Okay, go ahead.
The opposite sides are parallel.
You were gonna say the same thing. Opposite sides are parallel. Okay, so how do we tell if these are actual parallel and not just like slightly parallel? If they have the same slope. So how do I find the slope of this?
Rise and run.
Rise over run. Okay, so like y2 minus y1. If y'all are like formula friends, I don't know. I like plugging into an equation. I don't like doing the visual thing. Okay. But that's how you would solve it. Now, if you did do the visual thing, then here's what you would get. Ready? So from here to here, from C to B, okay, or BC, we would say up 1, 2, 3, 4, 5, 6, 7, and over 1, 2. So that would be 7 over 2. And we would check over here with AB and see if it's the same thing. So we would go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2. So both of those are the same. That means that BC is parallel to AD. Is that notation that you recognize?
Yeah.
Yeah.
So you counted.
I counted from this point up to this point. So I went up however many units and went over however many units. And I put 7 over 2.
So you don't just count lines. You go up
and then over. Because remember, rise over run. Now, I think it was John Jason that agreed with me. If you wanted to do it the equation way, you would assign these points. You would say like, down here, this is x1, y1, and this is x2, y2. And you could plug it into this formula and you get the same thing. Okay.
Okay.
Can
you should get 7 over 2.
You should get 7 over 2, which is 3.5. Okay. If you will take a second, I want you to prove that AB is parallel to DC. Okay. Prove that AB is parallel to DC. So I want you to find the slope of each. And again, it should be the same. So what'd you get? What'd you get for the slope for this guy?
Wait, what?
Okay. So let's talk about it really quick. So how many units up did we go? 0. And then how many units to the right did we go? Okay, and then what's 0 divided by 13? Is 0. Okay, no, undefined is different, but we'll talk about that in a second.
Oh, it's when you.
Yeah. Right. You can't divide something by 0. The best way that I think about this is, let's say you have 0 things and you want to break it into 13 groups. Well, how many groups are you going to have then? 0, right? If I took 13 things and I broke them into 0 groups, that doesn't make sense. I would have to have at least 1 group. Does that make sense? So that's why this guy is undefined. Yeah. Okay. So both of these are 0, which means that they're parallel to each other. Cool. Okay. That's fine. You can do it that way too. Okay, so what properties of a rectangle involving slope can help you prove that this is an actual rectangle?
You got me there.
Opposite sides are what?
The things are right.
Opposite sides are parallel. Okay. And then y'all learned something about them being 90-degree angles and something about the fact that opposite sides are the same length, right?
Whoa, you're not gonna tell me? No, you don't deserve to know.
What?
What?
Okay. So what properties of a rectangle involving slope could help you prove that ABCD is a rectangle? So really we're focusing on the opposite sides are parallel. Okay. So really quick, draw this rectangle on your paper. Okay, make sure that you write down the points. If you want to graph it on your paper, fine. But if you want to just draw the point or write down the points, that's fine too. I want you to tell me if DC is parallel to AB and if BC is parallel to AD. The points are 0, 14 for D, 6, 16 for C, 10, 4 for B, and 4, 2 for A. 0, 14 for D, 6, 16 for C, 10, 4 for B, and 4, 2 for A. Take a second, figure out. Okay. So again, you could do this. I'm going to call it the John Jason way,
Yes, sir.
the equation way, or you could have counted. Okay. So I'm going to show you the counting way. And again, you should get the same thing. So going up, that would be 2 units. To the right, it would be 2, 4, 6 units. So this would be a slope of 1/3. Down here, I would do the same thing. Up 2 units, over 1, 2. I'm sorry, that's 6. So that would be 2 over 6, which is 1/3. So AB would be parallel to DC. So that first one is true. Okay. Now again, on this next one, I would go down. That's a really far away. 2, 4, 6, 8, 10, 12. And then to the right, 2, 4. So 12 over 4. Okay. And that would be negative. It doesn't really matter as long as they're not crossing each other. Okay. And then this one would be down 2, 4, 6, 8, 10, 12, and over 2, 4. So 12, 4. And again, those would both be negative because they're a negative slope. Okay. Since they're the same, then that's true. Okay. Questions on that? Okay. All right. I'm not going to bore you with this, but here's a rhombus. Okay. If you didn't know what a rhombus actually looks like. Okay. What is it? Yeah. Yeah. Okay. It kind of looks like a kite. It kind of looks like a diamond. Huh? It looks like a square, but like you kind of tilt your head, doesn't look like a square anymore. Okay. Still the same concept applies. Opposite sides are parallel. Okay. For most of your quadrilaterals, opposite sides are parallel. Okay, so we're going to
most quadrilaterals have opposite sides.
Opposite sides are parallel, all of them. Okay. So really quick, we are going to kind of switch gears. I'm going to show you a different PowerPoint. I kind of went out of order. I apologize. Okay. So we're only going to do 2 of these. On your paper, go ahead and draw this little chart, and we're going to do the first 2 rows together. Okay. So we're going to do the first 2 rows together. Okay. So slope of line 1 is -2/5. Slope of line 2 is 5/2. Slope of line 1 is 2. And slope of line 2, I'm sorry, slope of line 1 is 2. And slope of line 2 is -1/2. We want to figure out the product of these 2 slopes. Okay, remember, product means that we're going to multiply. So we're going to multiply straight across. What's -2 times 5? -10. And then 5 times 2? Okay, -10 divided by 10 is -1. Okay, on this next one, we're going to multiply across. 2 times -1 is going to give me -2. And remember, this is going to have a denominator of 1, right? So 1 times 2 is going to give us, okay, so -2 divided by 2 is, okay, that's all I wanted you to remember from this. I want us to be comfortable with multiplying fraction. Okay, I want you to write on your paper, write an equation in slope-intercept form. Okay, so you're kind of summarizing this. All right, so on your paper, I would do, on the left-hand side, I would say slope-intercept.
Oh.
And I would say passes through the point 5,7. And this is example 1, if you want to title it on your paper. And you want it to be parallel to the line y equals -x minus 6. And you're going to summarize the same thing for this guy over here. Take a second, write that information down, and we're going to talk through. Okay, so throw back to algebra 1, probably y'all's like 7th grade year. Slope. Oh, okay. So slope intercept form. Okay. What does that equation look like? Does anybody remember? Y equals mx plus b. Okay. Now, that's what we want it to look like at the very, very end. Okay. There's another equation that you might want to know. It's called point slope form. Okay. And so that's going to look like this. Y minus y1 equals m times x minus x1. And again, this is called point slope form. Okay. I would know that one by heart. They normally don't put it on, I say that, and it'll probably be on your formula sheet, but you should know it because it's been a hot minute since you actually learned it. Yes, point slope. Have you not? What? Oh, amazing. Okay. So this one's going to be your best friend. Okay. Point slope.
I've seen that.
Thought so. Wait. Okay, so let me show you how you're actually going to use this. Ready? Okay, so you're going to actually use point slope form and then manipulate it to be slope intercept form. Okay, so I know. Okay, so what is the slope of this line right here? -1. Okay, so we're going to plug that in for our m. Okay, so we're going to say -1 for our m. Now the point that they give us was 5,7. This guy is going to be my x1. This guy is going to be my y1. And we're going to substitute into this equation. So we're going to have y minus 7 equals -1 times x minus 5. Okay, so for my people who were like, what the heck did you just do? All I did was I took this equation that I have up here for point slope and just plugged in the information that they gave me.
Oh, m is the slope.
M is the slope of the whatever the line they give you. Okay. Now, does this look like slope intercept form? No, it does not. The way we do that is we try to get y by itself and move everything to the other side. So what you're gonna do, what you're gonna do is you're gonna distribute that -1 and then move that 7 to the other side by adding it. So y equals -1x. 7 plus 5 is gonna give us 12. All right, so really quick, ready? We plugged everything in. We distributed that -1.
Right.
We move the 7 to the other side. So our final answer is going to be y equals -1x plus 12. And now we're in that slope intercept form. I know, I'll give you a second. Okay, so we're gonna do the same thing for this other one. The only difference is we're trying to make it perpendicular, right? Okay, so think about it. If 4 is the original slope, what is the negative reciprocal of that?
-1/4.
Exactly, y'all are brilliant. Okay, so -1/4. And remember, our point is 4, 5. So that means that we're just gonna substitute into here. Okay, so we're gonna get x minus 4 on this side and y minus 5 on the other. Okay, and then now we're gonna do the same thing that we did on the last one. We're gonna distribute, move everything to the right-hand side so that we can put it in slope intercept form. So we're gonna distribute that -1/4. And remember, multiplying fractions is gonna come into play here. I know. It's gonna be -1/4 x on this side. -1/4 times -4. Let's think through this. What's -1 times -4? 4. And then 4 times 1 is gonna give us, so 4 divided by 4 is 1. Man, y'all struggling. Okay. Then we're gonna add that 5 to the other side because we want to get y by itself. So our final answer is going to be y equals -1/4 x plus 6. Ta-da. I know, I'm so great. People be crazy. Remember how mathematicians be crazy? They like to ask really weird questions and have it in different forms. So for instance, we have 2x minus 3y equals 21. So on your paper, I would probably say example 3. Okay. And I would write 2x minus 3y equals 21. Okay. Now these questions are, do you agree or disagree? So the first one says the slope of the line is 2/3. So how would we figure that out? We have to put it in slope intercept form. Okay. So we're going to take 2x minus 3y equals 21. And we're trying to get y by itself. So we're going to subtract 2x. And we get -3y equals -2x plus 21. And then we want y by itself. So we're going to divide by -3 on both sides. And so this is going to give me positive 2/3 x, because remember, negative divided by a negative gives me positive. 21 divided by -3 is -7. So is the slope 2/3?
Yes.
Yes. So I agree on this first statement.
Oh, I get it.
Does that make sense?
I never knew how to do that.
This is too hard. Basically, this unit or this part of the unit is just, hey, can you rewrite this in a different form and then do these key features apply? That's what it's asking. Okay. Now it says a line passing through the coordinates 6, 8, and 0, 4 would be perpendicular to this line. How would we take these 2 points, okay, and figure out if they're perpendicular to this line? That's one way. You could do it. No, like really, you could plug them in and then see if it's perpendicular. What's another way though? Mathematical way.
So you take it and then.
John Jason, what's your favorite way to do things? The formula. Okay, so we're gonna find slope of this guy. Okay, so when you find slope of this one, 6, 8 is gonna be our x1, y1. 0, 4 is gonna be our x2, y2. And we're gonna substitute into our slope formula. So this is gonna be 4 minus 8 over 0 minus 6. What's 4 minus 8? Negative 4, right? And then 0 minus 6 is gonna give me what? Okay, and negative 4 divided by negative 6 can be simplified.
4, 6.
So 4, 6, or both of those are divisible by 2, right? So we're gonna get 2/3. Is that perpendicular to or parallel to the other line? It's parallel. So we're going to disagree on this one. You're gonna have one of these type questions. It's gonna be parallel or perpendicular
Wait, why is it parallel?
because it's the same. Remember, if it's the same, it's parallel. If it's a negative reciprocal, it's perpendicular. Okay, now on number 3, it's asking if this other line would be perpendicular to this original line. Okay, so we're gonna take this equation and I would probably change this to slope intercept form. Now, what you could do is kind of what Logan was saying and plug it into Desmos, see if it crosses. Okay, but to make sure that it's actually perpendicular, I would rewrite this guy in slope intercept. So we're gonna take 3x plus 2y equals negative 4. We're gonna move that 3x to the other side by subtracting. So this is gonna give us 2y equals negative 3x minus 4. We're gonna divide by 2 on both sides. And so we get negative 3/2, and this is gonna be minus 2. Looking at this slope, this would be perpendicular, so we would agree. The way you figure this out is you take your original equation, okay, and you substitute in 9 and 0 into this equation. So that's gonna give you 0 equals 2/3 times 9 minus 7. Okay, and when you simplify this, this would give you 6 minus 7, which is negative 1. Is negative 1 equal to 0? No. Since it's not, then we're going to disagree, and that means that this point 9, 0 does not lie on this line. Okay.
Oh, wait,